The next thing we're going to move on to then is mainline executable programs. By the time we have completed this exercise, you will have something to run. The mainline one, it's a bit more involved, just that you've got more things to do. So let's give it a go. Mainline projects then. There's two types of mainline projects templates available in Visual Studio. The first is what we call a traditional application. And this project type basically builds a single DBR. Irrespective of how many files you put into the project, you will create a single runtime, a single DBR. So you can put multiple source files in, so you can put routines and your program and this and that and everything else, and you'll get a single DBR out of it. The second project type, which is the one we're going to use, is a multi-mainline project type. Here you can reference or include any number of source files, and each one will produce a DBR. Okay, so each one is considered the mainline program. So you can build multiple programs from a single project. Multiple mainline projects, you can also specify a startup object. The startup object is the particular program you want to run when you say, I'd like to run or debug this from within Visual Studio. And that's the DBR that will run. The multi-line projects in general are a lot more flexible, and you don't need a project for each mainline program you've got. If you've got lots and lots of mainline programs, lots and lots of projects in a solution, really slow Visual Studio down, and can be a bit cumbersome to navigate around in the Solution Explorer and all that kind of stuff. It's much nicer, much neater, and much more efficient to put them all into a single multiple mainline program project and be able to say, I'd like to run this one today, I'd like to run that one tomorrow, sort of thing. Now, you can reference any and all of the project types, including ELB and the executable library projects and object library projects, etc., and the repository projects. And then if you do that, if you change something in your object library, that'll cause the ELB to build. If you reference the ELB in your mainline projects, that'll cause your main lines to build. Now, that's a little bit of a downside, because if you change an internal piece of code inside a routine, that'll ripple up and cause the main line to rebuild. But it shouldn't have needed to rebuild, because your main line's not changed. The way it's calling the routine hasn't changed. It's just a little bit of a bug fix or a tweak that you've made inside the routine. Development are looking into how we can not require the change unless the signatures change. So that'll improve the performance of the build in future releases of the SDI. So as with the other project types, we have project templates that we can select from, as you can see on the screen. Under the Synergy DE traditional branch, we see the Synergy traditional application and the multi-main line. As I say, for our workshop, we're going to focus on the multi-main line. Now, I was asked a question. We had a few people test these workshops back at the ranch, as they say, in the support department. And one of the lads came back and said, why are you using multi-main line project, Richard, in your workshop when you've only got one program? Why not use a traditional DBR? Very simple. What it does is show you that, one, there is a multi-main line project template in Visual Studio, and two, it shows you that you can set that as a startup project and set the files as a startup object. Even though there is only one, you still have to specify that one as the startup object. Where with the traditional DBR project, you don't need to set that. So it just demonstrates that additional step. The traditional application, generally, if you're going to use that, it's generally for little test programs. So you create a little test program, run it, and throw it away. So, as before, select the project template and give it a name. I think we're going to call ours On Vinyl TK for toolkit, obviously, maintenance. And as normal, generally, leave the location alone and it'll put it under the solution folder, and life will be good. By default, the project template creates a couple of mainline sources called Program 1 and Program 2. We're not going to use those, we're not going to add code to those, we're just going to delete them and throw them away. As the main line is the sort of top of the food chain when it comes to running things, remember to make the project the default startup project. And you'll see how to do that in the instructions if you don't know how to. And when you do so, it'll make it bold, as you can see on the image. Once we've added programs to the project, as I said, you can specify the startup object. The object is which program, which main line do you want to run when you do a debug or a run from within Visual Studio. When you do set that, you can right click it and say set a startup object. That particular source file in the project will be bolded, just like the project is bolded. So you get a visual indication of which program will run when you actually run from Visual Studio. So once we've got the project in and built, we can reference other projects. For example, we can reference our On Vinyl executable library, our ELB. We can reference any Synergex or system libraries that we need. For example, the toolkit. We can reference our repository if we need the repository. Many mainline programs simply call into routines and off you go, but some mainlines will actually include information from the repository. So at this point you have written or added your code to the project, reference your application libraries, and everything should be ready to build, or not as the case may be. Okay, it's going to be a bit tad annoying, isn't it, when we try and run things and build things and we get a nice little error that says ELB name too long. Normally we don't want to highlight issues or errors because everything in Synergy land just works normally. But this one, you may get this, and we will get this in the workshop, because I didn't set the workshop up to get this, but because I'd given things long names, meaningful names like on vinyl executable library, I ended up getting this and thought, oh, okay, let's highlight it, not to show that we've got bugs, but to show that if you've got long ELB names in your application, you can get around it. Obviously, the simple answer is to reduce the size of the ELB name. And this can be done by changing the output name of the library, which can be found on the Application tab inside the Properties for the Executable Library project. So here we're changing the name from On Vinyl Executable Library, and at the bottom you'll see it says On Vinyl ELB. Okay? Things should run and build from that point. Just one note though, because you're changing that, if you were deploying this into an existing system, those name changes may break things, so just be a bit cautious if you're putting something back into the real world. Okay, so it runs, and you have the fabulous UI toolkit experience in front of you, and you're all feeling that warm, glowing feeling inside of just how good this program looks. Now, I'm not talking really about how the Synergy UI toolkit looks, but as I said at the beginning of the workshop, this is not a masterclass in UI toolkit, but more about actually how to configure and build the environment. But that said, we are going to do a couple of things just to tweak the program so you can see how things will then build because of changes you've made. We've no titles on the windows. It'd be nice if we did. So one would say vinyl collection and one would say vinyl details, for example. We need to add those into the window script. By doing so, that should force the window library to build, which will force other things to build, which will make a rebuilt window library, and life will be good. Also, we may want to add prompts and various things onto the form. Now, we could go into the script file and add them there, but that's not really the recommended approach. We'll put them in the repository. Now, if we're going to maintain the repository, do we load the repository program and maintain it through there, or do we edit the schema file? Well, in the workshop, we're going to edit the schema file, and that will cause a repository to build. If we build the repository, that will cause the executable library to build. If we build the executable library, etc., the main lines. So a change over here will ripple up the build system all the way up. So we'll add some prompts to the program as we go. And things will hopefully force everything up to build. So as I say, we can improve the basic UI by applying the attributes directly onto the structures within the repository. Remember when we loaded the repository from those include files? It just brought the field name, the field type, and the field size. Nothing else was brought in, because that's all the compiler needed. That's all we need to build the actual code. But for the UI, we need the additional information. So here in this example, we've got the country structure. Two fields are defined, the code and the name. The code, simply an alpha3. What we're going to do is add a prompt to it, and we can add some info line, so we'll see that as we go on to the field. We're going to say that it's uppercase, and we're going to say that it's required. Okay? Some of this is not going to be used in our little test program, like the required stuff, but the uppercase stuff will be. It'll force the entry of uppercase. So you're defining the metadata inside the repository to determine how the program runs and the program looks. The window titles, as I said, they'll come directly from the script file. You can't define those in the repository. So what we'll do is edit our window script, our maintenance.wusk file, and very carefully, because you want to type this in correctly so you don't upset the script compiler, underneath the .input you'll do a .title of vinyl collection, which will be the input window for the list, and vinyl details, which will be the input window for the actual details, blowout details. Making those changes, because they're content files in our window library project, that'll cause the build system to build them into the window library for us. And it will hopefully look a little bit nicer. To ensure that we have all the elements linked together so things build when changes are made, we need to build or define the inter-project dependencies. Now, generally that's done for you. And the simplest approach is to reference one project from another. So if you reference the repository project, you're making a dependency between this project and your repository project. And that's usually all you need to do, as long as that project can be consumed by the target project. So for example here, the object library and the window library and the mainline programs all reference the repository project. Now, strictly speaking, because the window library is not a true project type, it does not need to reference the repository, but changes to the repository would normally require window libraries to be rebuilt, so we do reference it. The object library and the mainline executable projects have dependencies to the window project. Now remember, the window project is a console application because it's a sort of fudge project. Okay? It's just a project that allows us to, using scripting and pre-build events, to build a window library. So we can't reference that. We can't say this mainline needs to link against our console application. It doesn't make sense. But we can put dependencies in place that say this project is dependent on that. It doesn't link against it. It doesn't get any information from it, but it is dependent on it. And if it's dependent on something, if that dependency builds, then the target will be built. So that's how we can make sure that everything builds and links together. The executable library references the UI toolkit and the object library. So if the object library changes because of a repository change or a source code change, the executable library will be rebuilt. As I said, you can have additional code inside your executable library as well as the feed from the object library. If those changes were made, that would cause the library to be built. We define dependencies at the project level. This allows us to link projects together. So if a sub-project builds, the reference project will also build, or the dependent project will cause it to build. For each project, you can define the dependencies. For example, for the mainline programs project here, the on-vinyl TK main project, we specify the window library as a dependency. As I said, we don't link against it. There's nothing to link against. But if we say it's a dependency, then if the window library builds, the chances are the main lines don't need to be rebuilt, but they might do. So we can put that dependency in and belt and braces build approach. The executable library will already be defined as a dependency because we referenced it. So if you reference it, it adds it to the dependency list anyway. Okay? Exercise 4. If you do a refresh, you should see the proper link on the page now. You're going to create a multi-line program and add some source files to it. I think there's one program. Yeah, there's just one program you're going to add to it. Define references, define dependencies, and hopefully everything will build. And once you've built it, it should run. And when you run it, you'll think, that looks ugly. I need to have some titles on my windows and some field information, prompt information. So you're then going to edit your schema file and it will all rebuild and run for you.